Alright guys, this would be the example for the series circuits. So example number 1, in the circuit below, find the total resistance, the current, the total power, and the voltage dissipated in each resistor. So notice that we have a series circuits right here with 3 resistors. The first question, or the first thing that we need to find, is the total resistance, which is right here, the total resistance. So the total resistance of this circuit would be, let's write solution directly. Solution. So first thing that we need to find is the total resistance. So the total resistance of the series circuit is R1. We just have to add all of them, R2 plus R3, since we only have 3 resistor. So R1 is 50 ohms, R2 is 60 ohms, and then R3 is 70 ohms. So therefore we would have a RT with a total resistance of 180 ohms. So this would be the total resistance of the circuit right here. So we already have the total resistance. The next thing that we need to find is the current. So the current, guys, let's find the current, or the total current. So IT in terms of Ohm's law is just equals to the voltage over the total resistance. Since we already have the voltage right here, the total voltage, and we already have the total resistance, we can now find directly the total current. So substituting the value, so VT we have 120 volts right here. So 120 divided by 180 ohms. So putting that into a calculator, therefore we would have a total current of, that would be 0.67, sorry, that is 0.67, that would be amperes. So this would be our total current. That's good. So check for the total current. Right now we are going to find the total power. So total power, let's find the PT. So we can use the I squared times RT, since we have already the total current and the RT. We could also use the IT times the VT. So if you use that, either of that, is we would have a result to the same outcome. So right now we had to use a IT squared multiplied by RT. So IT squared we have here 0.67, that is squared, times RT is 180. So we would have a total power of the entire circuit of, putting that into a calculator, we would have 80.8. So the unit would be watts. This would be our PT. So if we try to use another formula, PT is equals to VT times IT. So that's, we have 120 volts multiplied by 0.67. We would have, putting that into a calculator, we would have the same outcome, that is 80.4, which is approximately the same to what we have right here. So we already have the total power. Let's check. And right now we're going to find the voltage being dissipated in each resistor. That means that we need to find the resistor, the voltage being dropped across R1. Let's draw that's V1. This is V2, voltage across R2, and then let's put V3 right here. So in terms of finding the voltage dissipated across each resistor, we can use, for V1, we can use either the Ohm's law or the voltage divider formula or theorem. So right now we just have to find the V1 in terms of Ohm's law. So V1, that would be I1 or IT, since all of the current are the same, so let's just put IT right here and then multiplied by the resistance R1. Okay, putting that into substituting all the value that we have 0.67 amps, and then R1 we have 50 ohms. So we would have a V1 or a voltage drop across resistor 1 of 33.5. That's 33.5 volts. So we already have V1, and then we need to find V2. That's the same IT or I2, since we have the same current, and then multiplied by R2. Do we have 0.67 amps or amperes, and then R2 we have 60 ohms. Therefore we would have a V2 or the voltage being across R2 of that would be 40.2 volts. So let's square that one. So we already have V1 and V2. The last thing is V3. V3 is the same. We have I3 or IT multiplied by R3, which is equals to 0.67 amps, and then multiplied by the R3 right here in the circuit, which has a value of 70 ohms. So putting that into a calculator, we would have a value of 46.9 volts. Yeah, that would be the the voltage across R3. Basically, we can also use the voltage divider formula for the voltage dissipated in its resistor. So if we try to check that one, we just have to erase this one. Right now we are going to use the voltage divider formula for V1, V2, and V3. So let's have V1 right here. Let's put voltage divider formula. Let's see if we if it really works, or both are, if we would have the same outcome. So V1 would be equals VT multiplied by R1 divided by RT. So that would be the formula. So we have 120 volts for VT multiplied by R1. We have 50 ohms, and then divided by the total resistance, which is right here 180 ohms. So ohms would be cancelled, so we would have a value of voltage being dissipated in, or voltage across R1. So let's put that into a calculator. That would be 33.3 volts. Let's box that. So notice that we have the same, approximately the same outcome as when we use the Ohm's law and the voltage divider. So for V2, that is the same, VT multiplied by R2 divided by the total resistance. So substituting the value 120 volts multiplied by, we have R2 of 60 ohms and then RT of 180 ohms. That's ohms, cancel ohms, and then putting that into a calculator, we would have a V2 of 40 volts. 40 volts. We could box that one. So notice we also have approximately the same outcome. And then let's go to V3. Let's put V3 right here. That is equals to VT multiplied by R3 divided by RT. So substituting the value 120 volts multiplied by R3, we have 70 ohms divided by 180 ohms. So we can cancel ohms. So putting that into a calculator, we would have a value of 46.67 or 46 0.7 volts. It's box that. So notice that we also have the same, or approximately the same outcome right there. So that's it for example number 1. So let's check the voltage dissipated in this resistor. Let's go to the last example, which is example number 2. Okay, right here guys, you can pause the video and you have to, you can solve this on your own, and let's see how it works. So we have a series circuits right here, the same also from example number 1, which has a 3 resistor in series. Right now we need to find the voltage, total voltage, the also the V1, V2, and V3, which are the voltage across resistors, and also we need to find the total power. So first thing, let's write solution right here. So we need to find the value of the voltage, the total voltage. So what is the formula of the total voltage? So that is Ohm's law, IT multiplied by RT. Since we already have the total current right here, which is 2 amps, we would have just only to substitute that one. However, we haven't have the value yet of the RT, so therefore we need to find the total resistance of the circuit. So let's put RT right here. That is equal to R1 plus R2 plus R3, since we have 3 resistors in series. So R1 is 1 kilo ohms. 1 kilo ohms plus R2 is 5 kilo ohms. R3 is 600 ohms. Therefore, we would have RT. Let's convert this first into ohms. So 1 kilo ohm is equal to 1000 ohms. And then 5 kilo ohms is equal to 5000 ohms. And then plus the R3 is 600 ohms. If we try to add that one, we would have a 6600 ohms, or 6.6 kilo ohms. So we are now having the total resistance. So let's put that right here. We have 6.6 kilo ohms, and then before we input that into calculator, make sure that we transform the kilo ohms into ohms, so that we would have the correct answer. So that would be 6600 ohms. So VT therefore is equals to, putting that into calculator, how much would it be? That's 13,200 volts, or we have 13.2 kilovolts. So both are the same. Right now we already have the total voltage. So right now we need to find V1 and V2 and V3, which is the voltage across resistors. We have V1, we have V2, and then we have V3. So we can use the Ohm's law, and we could also use the voltage divider. So since Ohm's law is a lot easier, so let's use it. V1 is equals to IT, or I1, multiplied by R1. So we have the value of IT, which is 2 amps, multiplied by the resistor, which is 1 kilo ohm, or equal to 1000 ohms. That means that we have voltage across resistor, which is 2000 volts, or 2 kilovolts. So let's put some square. So we already have V1. We need to find V2. That would be IT multiplied by R2. IT or I2 is equals, are both the same, I mean. And then we have 2 amps right here. R2 is equals to 5 kilo ohms, or equal to 5000 ohms. So therefore we would have 10,000 volts, or we have 10 kilovolts voltage drop across R2. And then we have V1 and V2. We need to find V3, that is IT or I1, they are the same again, multiplied by the resistance 3. So IT is equals to 2 amps, or 2 amperes. R3 is 600 ohms. Therefore we would have a V3 of, that's basically 1200 volts or 1.2 kilovolts. So let's check if all the voltage drop across the resistors are equal to the VT. So since VT, we could also conclude that VT is equals to V1 plus V2 plus V3. So we have V1, which is 2 kilovolts, plus V2, which is 10 kilovolts, plus V3, which is 1.2 kilovolts. So summing all that up, we would have a value of 13.2 kilovolts, which is approximately or exactly the same to what we have here in the first place. So that means this is correct, this is correct, this is correct. So we have the VT, the V1, the V2, and the V3. Right now we only need to find the power total. So power total, let's put that right here, power total. So we could use since we have IT, VT, and RT, we can use VT multiplied by IT, or you could also use IT squared multiplied by RT. Therefore, PT is equals to, what is the value of VT? We have, let's use 13,200 volts multiplied by the value of IT, which is 2 amps. That's huge. So therefore, the power or the total power would be equal to 26,200 watts. 26,400 watts, or equal to 26 point, or 26.4 kilowatt. That would be our total power. So if we try to find the value of P1, P2, P3, and then we have to sum all that up, the summation of all of that power would be equal to this. So that is, guys, thank you for watching for this video, and I hope you understand well and study well. And if you have a question, please comment down below and I will answer that right away. So thank you so much and God bless.